Hey, I'm Geoff with WizzyCom. I'm here with Leslie, and we're going to talk a little bit about RF over fiber, specifically an application example of using the BFL to do a single carrier transmit over fiber with the MTK982. So to do this, you'll need a few pieces, one being the MTK982, which is over here in a rack by our table, a BFLT on your local side, and then if you draw a dotted line down the middle, there is 1,000 feet of single mode fiber that connects to Leslie, who is our remote zone.
Yeah, with my receiver, probably a body pack and IM receiver, so I have to, which is our goal for this scenario, is just increasing the level of coverage of our IM system. So placing multiple antennas, of course, that they won't interfere to each other's, and being sure that if I'm a journalist, a musician, or whatever artist or a reporter, I can walk all over my area, whether it's main stage, backstage, paddocks and TV compounds area, without losing the signal coming from into my IFB piece.
Yeah, and so on your remote side, you'll just need a couple of components, and this is for doing single carrier. There are a lot of situations where you can do multiple, and that kind of changes. The biggest, it's all RF math, and the biggest thing that changes is which amplifier you're using. And we make a couple of options, but for this, we'll just talk about single carrier. And so for that, you'll need the BFLR, and our main amplifier for that is called a PAW, and then an antenna.
Yeah, correct. This is pretty much the same setup that Visicom has been using for years into big broadcasting events or big live events. So combining RF over fiber and RF amplifiers and antenna system and combiners and everything. So this is pretty much the same concept, just reduced into a more compact and easy to carry around solution. So we replace the RF over fiber rack-mounted units with the BFLs, T and Rs. We replace the rack-mounted amplifiers with portable PAWs that can be also mounted directly on passive antennas, which are called LBPs. So there are two different options, which is a very handy solution. It's something very, very simple to get around with. So the concept is that, okay, let's take the know-how that we have, just reduce it into size, but not in quality. That's of course the big thing.
One of the big things with this, we took the same lasers that are in the MFL. And these are all, one thing that separates WizzyCom is these are purpose-built lasers to deal with the dynamic range of wireless microphones and to deal with the power levels of IFB or IEM's carriers.
Yep,
and when
absolutely.
we say IEM or IFB, that typically just refers to IEM being a stereo carrier or IFB being a mono, like a narrowband carrier. Same way works the math either way on this system. So what we want to do with this is kind of break down some of the conceptions or misconceptions of using RF over fiber in transmit applications and show this is an incredibly attainable solution for a number of applications. As you were saying, racetracks, film and field, broadcast news, anything you need, you can do this with just a few components. Yep. So we get into a few things we start is, always make sure your fiber is clean. 90% of our applications, as we've talked about before, is 95% of the problems that are reported are usually misdiagnosed, and almost always is just dirty fiber. Yeah. And it may look clean to your eye, but it could be the oil from your skin or dirt you can't see. Clean the fiber.
Yeah, that's a perfect starting point.
Yeah, always. If you're having problems, we're always happy to help. But the first thing we're going to ask you is, have you cleaned your fiber again?
And when they say yes, we say, okay, just re-clean them.
Just go through it again.
Just to be sure.
It will feel almost repetitive, but cleaning your fiber will solve almost every problem. So next we get into talking about managing your RF levels. And managing it for microphones is different than this because when you come out of your MTK 982, you'll see there's two connectors on this for each channel. On the 982, there's a BNC and an SMA. The BNC would plug into your normal CSI 16. It's your local zone. Your SMA is a 0 dBm reference copy. And the reason we utilize this is you can convert out of the SMA, go out of that straight into the BFL. But to do that, you can use our recently updated app or on the BFL itself, go into your menu, RF menu, and settings, and make sure mode is set to IFB. And what this does is changes what the RF input level is working for and just making sure all levels in the gain staging are matched across.
This is designed to work with a signal which is max 0 dBm, so approximately 1 milliwatts. This is for a specific reason because the fiber cable cannot carry RF power. So basically what we need to send from our local zone, our control room, our OB van, whatever it is, down to the remote side, we need to send the basic information needed to create a second point of amplification. So basically the frequency, just to name one. So what we are going to send and reconvert over the fiber, we receive the frequency information here, send them out over a copper cable into the RF amplifier that, of course, re-amplify the signal and switch and send it out. What we can do from this unit is also we can boost the PAW, the amplifier, the tiny amplifier, so we can enable it from the app or from the menu here. That's also very important if you want our booster to be on. So our amplifier, yeah.
Yeah, so it's a shift. When you're in antenna mode, the BFL-T has the booster or bias output voltage. When you're in IFB mode, the BFL-R has the voltage out. Yeah. And it's all about just keeping a note of where your T and your R belong in your application, because it can shift in how you're doing it.
Yeah, that's a very important thing to keep in mind, because the typical thing that the people ask, maybe they are familiar with using fiber in reception, so they place diversity antennas, and then the real limit of how many body packs or handle mics you can receive over fiber is the sensitivity of the receivers themselves that they are using. So it depends. If it's a very good system, you will have a lot of transmitter on the other side. If it's a so-and-so receiver, probably you have to decrease the amount. But the fiber itself is not adding problems. It's like basically just solving problems. When you work on the other side with IM, IFP, of course, these rules are a bit different, because you cannot just simply combine 16, 20 carriers into one cable, one combiner, then send it over fiber, use a tiny amplifier like this, and pretend to have 20 dBms or 100, 200 milliwatts per carrier with no intermod. So that's not how RF works, unfortunately. That would be nice. But there are ways of doing this. And we might have other videos in future where we explain also how to do these more complex situations. But the important thing is that keep your power low when you enter the local BFL-T, and then use remote amplifiers to lift up your signals.
Yeah, because as we talk about, you can do multiple carriers. I mean, we tend to say, the safe max per strand or per fiber transmit laser is 4, and you have to manage your level back. So you've got to bring it back to at most about a negative 13 dBm if you're running 4, but you change amplifiers in that situation. The PAW is an amplifier, but the one for that situation is what we call an MPA4. But in all of this, you kind of come into a new question of, well, in my legacy system, perhaps I can't use multiple transmit antennas because I've had issues with phasing and all these other things. But what happens is with the Wisicom MTK, we use a technology called direct digital synthesis. And what this does is in the transmit carrier, it has a clocking built in. So as you split antennas, whether it be your local zone or you add fibers and do all these other things that you can get into, if you want optical splits and all these other things, the belt pack, the MPR50, will always see the transmit as one fully synchronous carrier as you walk from zone to zone. So if you're on a large, we'll say, performance, venue stage, and you have in monitor world stage left, you have your transmit antenna, but you need to put your principal artist out on a, 100-meter thrust. Yeah. You can put a fiber zone out there, and as they walk from one point to the other, the belt pack will never have any, phasing. It'll just continue going as long as there's signal. Yeah,
the true diversity belt packs, or the MPR50. That's also the big advantage of working in true diversity. Talking about a receiver.
And it's it's all kinds of goes together as an ecosystem. Yeah. You can use this to do many things with many other systems, but with the MTK, with the PAW, with the BFL, it becomes one ecosystem that allows you to do a lot over a lot of different frequencies. But with this, if you have any questions or any applications you'd like to, just talk through, and we'd be happy to help and explain, send us an email to support@wisicom.com.